All right, today's lesson is lesson 7.1. It is day 2. The homework that goes along with this is page 380. Use your graphing calculator. The green coach lesson number 18 is due for a grade tomorrow, probably Friday, and do not forget Edmentum. Here are the answers to last night's homework, so you can pause this and check. This was page 377 and 378. I want you to do these problems right now for a warm-up. You can pause the video and do these. All right, this is a review for the benchmark. This problem, the cubed root of -8. What is it, Casey? Correct. Because -2 times -2 times -2 does give you -8. So the cubed root of -8 is -2, and that is the only possible answer. Because you need to remember that you're multiplying by yourself 3 times to give you -8. Okay, this one, the square root of -64. No real number. Because 8 times 8 is 64, and -8 times -8 is 64. You guys do not know a number that you multiply it by itself to get -64. So there's no real number. What about this one? The cubed root of -64. Justin? Correct. Again, -4 times -4 times -4 does give you -64. What about this one? The cubed root of 27, Aaron. Correct. Because 3 times 3 times 3 is 27. Now, this is the tricky one. The directions said list all roots. What is the square root of 25, Lexi? Thank you. Why? Because 5 times 5 gives you 25, and -5 times -5 gives you 25. So all roots or all answers for the square root of 25 is positive and -5. Okay. Go to this page. I'm going to pause this. I want you to do these 3 problems. Okay. Number 1, what is the square root of 84 to the nearest integer? We need to figure out what 2 perfect squares that are smaller than or greater than the square root of 84. What is the square root that is a little bit less than 84, perfect square? The square root of 81, which is 9, and this would be 100, which is 10. So the 2 perfect squares that 84 is located in between are 81 and 100. Which one is it way closer to? 9. Because it is only 3 away from the square root of 81. So it would be closer to 9. All right. Now, this problem, find the sum. You start freaking out because you see fractions with integers. Not integers, variables. But don't freak out. What do you need to do when you add or subtract fractions, Charlie? Which would be what in this case? 15. So I need to make both of these into fractions with a denominator of 15. First fraction, I need to multiply numerator and denominator by 5, so that will give me 10x over 15. Second one, I need to multiply numerator and denominator by 3, so it will give me negative 12x over 15. What is 10x over 15 plus negative 12x over 15? Correct. They are like terms because they both have an x. It's negative 2x over 15. All right. What is the value of x over y when x is negative 5/6 and y is 7/6? Well, I'm going to substitute. X is negative 5/6 over y, which is 7/6. All I do is substitute. What does this problem mean? Paige. Correct. Negative 5/6 divided by 7/6. How do I do a division with fractions? Keep, change, flip. Multiply by the reciprocal. 6 goes into 6 once, into 6 once. My answer is negative 5/7. Done. Questions? All right. That we're going to worry about later. Okay, I want you, I'm going to pause this. Okay, this class party problem. The first problem, or first scenario was Waterworld. And in Waterworld, it costs $100 to reserve the pool and $5 per person. So, when you start filling in your table values, if 0 people cost $100, 10 people cost $150, 20, 200, blah, 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 etc., and so on. Your equation is y equals 5x plus 100. Now, I think part of the hardest part about graphing these by hand is figuring out an appropriate scale. I did tens across the bottom for people, and I did by hundreds up the sides. So when I graph this, 0 for 100, or 0 people $100, 10 people $150, 20 people $200, etc., and so on. There's my graph. Then, pizza pie. The pizza pie. It doesn't cost you anything to rent it. It's $10 per person. So, 0 people, $0, 10 people, 100, 20 people, 200, etc. Your equation is y equals 10x. There's the graph. Then, skate to late party plan. Costs $200 to rent and $2 per person. So, 0 is 200, 10 is 220, etc. And the equation is y equals 2x plus 200. So, when I graph that, that's what it looks like. Now, I used colors, which makes it easiest to see. So I went over here, Waterworld, y equals 5x plus 100 is in blue. Pizza pie, y equals 10x, I put in red. And skate to late, I put in green, y equals 2x plus 20. Here it is. In this problem, we have 3 intersections. The only one that you can actually solve by graphing was this one right here, because the red line and the blue line actually go through 2200. They both go through 2200. So that was an easy one. So, pizza pie and Waterworld. If you had 20 people it would cost you $200 at either one of those parties. They would be equal in cost. Now, what I want to show you is this, graphing calculator. Look what I did. I typed them in order. The first one was Waterworld, 5x plus 100. The second one was Pizza Pie, 10x. And the third one was Skate to Lake, 2x plus 200. So I typed in all three. And then when I go to my window, I did some thinking. Now, mind you, we've already graphed these by hand, so that made it a little bit easier. I changed my x max to 50 and my y max to 500. Now, watch what's going to happen. I'm going to hit graph. And remember, I typed them in order as they were given in the party problem. So, first one is Waterworld, then Pizza Pie, then Skate till Late. If I want to find this intersection right here, that was the intersection of the first two equations. Watch this. Second, calculate 5. Now, when we've done this every other time, first curve, we hit enter. Look, what curve is that on? Up here, 5x plus 100. That's the first curve. Enter. Second curve, 2x plus n. Yeah, let's go with that one. Uh-oh. Hit enter. Yes. Hit enter? No. That intersection is 2200. Let's go find another intersection. Second, calculate 5. Now, my first curve is 5x plus 100. So let's go with that one again. Hit enter. Now, we just did this one. So, watch what I'm going to do. I'm going to use my down arrow. That's the third curve. That's the one I want. I want an intersection between the first curve, which I already hit enter, and the third curve. Enter. Yes, no. Hit enter. So, this point of intersection right there is 33 and a third and 266 and 2/3. Last but not least, second, calculate. Intersection. I don't want to use the first curve, so I'm going to scroll up. Third curve. Yep, that's what I want. I want third curve and second curve. So enter. I don't want first curve, so I'm going to go down. Second curve, enter. Yes, hit enter. What's the intersection between my second and my third curve at the top of that triangle? Is 25, 250. Now, we will talk a little bit more about this party problem tomorrow.